Hi students, today in this video we are going to see about stress analysis of beam. As you have read in strength of materials, there are three types. Majorly we classified three types of beam: cantilever beam, simply supported beam, then fixed beam. These are the three beams which normally we have seen. Today we are going to see about what is the stress acting on the beam. We are going to calculate it by using finite element software method. The finite element software we are using for this particular analysis, we use ANSYS APDL. APDL full form means Analysis Parametric Design Language. This is the full form for this ANSYS, right? This is the software which looks like this is the entire screen of the software, which consists of preference, pre-processor, solution, post-processor, gen result. As we have discussed in the earlier itself, in FEA you have a pre-processor, post-processor, then solution you will be getting, we will get a result, right? Today we are going to do a simple analysis of beam. Only it is a static analysis. We are applying the load on static condition, then you will getting a result, right? This is the entire beam diagram, which consists of Young's modulus 200 gigapascal, Poisson ratio 0.3, then length of the beam is 200 mm, then it is an I section. You have a 200, 150, you have a web will be a 200, flange will be a 150, then thickness will be 10 mm, right? Okay. This is the entire screen which is going to be ANSYS we are going to start it, right? First you go for preference. Now we are going to do stress analysis. We are not doing any thermal analysis. We are going to stress analysis, that is a structural analysis. I am selecting it, click OK. After I am selecting the structural analysis, I wanted to do with preprocessor. Go to preprocessor, element type. Preprocessor, element type, add. Preprocessor, element type, add. You will have a beam, right? You have a beam. You can select any one of the 2 node 189. 2 node 189. You can select it. You go for a beam, then you have a element type. You can go for beam and 2 node 188, right? Click OK, close. Next we want to assign the properties to that particular beam, right? Material properties, material model, structural, linear, elastic, isotropic. Why we are going to isotropic means we are going to analyze the steel material. So steel is isotropic material. It has a, if you take the direction of the property, it remains same in all three direction, right? 200 e power, it is a gigapascal. It is converted into Newton meter square means 9. Then Poisson ratio 0.3. Okay. Q. Okay. Right. Then we assign the element type, material property. Then third is going to be, I am assigning the section, right? I am going to assign the section. Beam, common section. You have a different common sections will be have in the square section. Now we are going to do with I section. We are going to do with the I section. First you have to think what is a W1. What is a W1? W1 value is 200. W2 200. Then W3 150, here plus 10, here plus 10, then 170. Thickness remains 10. This all I am given in mm, so that I wanted to given in meter, so that 0.2, 0.17, 0.01, 0.01. First I have given in mm, so that you have to given with a meter. Once if you answers, you have to start with meter means end with meter. Then only you get the result in Newton meter. Stress will be gotten in Newton meter square. You okay? You assigned the beam section, right? Next, you have to create the drawing. You have to create the drawing. Modeling, you go for modeling, create key points, inactive S. Create modeling, create key point, inactive S. Inactive, first you create a first point as 0. Initially I am start with the origin 0, so that I am putting a 0, give OK. Then second point, inactive S, give 2. What is the length I am given for the beam is, beam length is 200. Then 200, it is in mm. It is in a mm, so it is in a 0.2 meter. 0.2 meter. 2 points are created. This is the first point. This is the second point. Right? Next, I wanted to join this line, this point, so that I go for line, straight line. You can go modeling, create line, straight line. You can select first point and the second point. Give OK. You can select the first point and second point, give OK. Right? After that, you wanted to mesh this model, right? Initially, it is a CAD model. You want to convert this CAD model into finite element model, right? Mesh, go for meshing, mesh tool. Here you go for lines. You go for lines, select the line. This entire line has to be selected. Give OK. You have to divide this line into number of elements. I am giving this line into 50 elements, right? And see that I have created the 50 elements. A CAD model is converted into finite element model, right? After that, again you can pick a rise return button. Again this table will come. You have a mesh option here. You have a mesh option. Select the mesh option. Select the entire line. Select the entire line. Give OK. It is meshed. It is meshed. After that, you have keep a rise button and close the window, right? Next, after meshing, you have to give the boundary condition. You have to give the boundary condition. That means you have to give the load. First, we have to cantilever beam one end is fixed for all the regions, so that I wanted to fix this region, right? Define load, apply. Define load, apply. Displacement, right? I wanted to go for displacement, key points. Displacement, key points. This box will come. You select this key point where I wanted to arrest the all degrees of freedom. Give OK. Select all degrees of freedom where I wanted to arrest all the points should be all degrees of freedom. Give OK. After that, I wanted to apply the force acting on this beam. Force acting on the beam. What is the force? We can give it. We can see into our manual. Is 1000, right? 1000 Newton, right? You wanted to give it 1000 Newton. Force, you go for force, key points, force, key point, force, key points. Select this key point, give OK. I wanted to give the Fy direction, so that Fy, it is giving a downward, so I wanted to put into minus 1000 Newton. Right, I have given the load, right? See the load, I have given the load. First I have given a boundary condition. Here itself I go for again I am repeating, define load, apply, structural, displacement, on key points. I select this first key point. Then I go for structural, again force, on key points, select this point and apply load in Y direction, right? After doing this all things, I wanted to get a solution, right? I want to solve this equation. Solve, solution, you go for solution, solve current LS. You can give a current LS. Give the current LS, give OK. The solution is done. Once you got a solution is done, only your problem is correct. Whatever your step is followed in this process is correct, right? Close. I wanted to get a result, right? I wanted to get a result. General, right? Plot result, deformed, undeformed shape. Deformed, plot result, deformed, undeformed shape. This is the deformed before applying the load, is after applying some deformation will happen. This is 1.74 e power minus 0.5. This is a small deformation happened on a beam, right? I wanted to get this deformation in 3D, so that I go for a plot, style, okay, style, counter, style, size and shape. You go for a, again I am repeating it, plot, plot control, style, size and shape, click it. You can on this, right? You can on this, give OK. It means that you can go for this is the 3D view, right? You can go here and you can view the 3D view. This is the deformation. I wanted to get a stress value, right? Then you go for counter plot. You go for counter, same plot result, counter plot, nodal solution. You go for nodal solution. Stress, I wanted to get a volumetric stress for the beam. This is the volumetric stress of the beam. You can select deformed with undeformed shape or deformed shape. You OK. This is the value of this is the stress acting on the beam can be calculated, right? This is the stress acting on the beam can be calculated. The red color shows that maximum stress. A blue color shows that minimum stress acting on the beam. Always a minimum stress will be acting on where fixed condition only you will have a maximum stress. You can animation this view. Whatever you are doing, you can animation it. Plot control, animation, right? Deformed shape or deformed result. You can go star, y direction, volume stresses, you can give it. See how it is going to be deforming it. You can get an animation. It is going to be deform it. It can be moving it. Always a fixed end will be an see that fixed end there will be a maximum stress. Maximum stress always occurs on fixed end. So that fixed end the stress will be more compared to free end, right? This is the entire problem how we are going to get a stress value using ANSYS software for beam, right? Thank you for watching my video. Next class I will be doing another exercise related to structural analysis. Thank you.